Today we're going to be looking at proofs for angle relationships. When I look at my first diagram, I should see right away this is a 90-degree angle. Angle 1 and angle 2 comprise the 90-degree angle. I should also see that the measure of angle 1 is 3x plus 1, and the measure of angle 2 is 44. That is given in my diagram. I also said that angle 1 and angle 2 are complementary. That's given in my diagram. Based on this information of being complementary, I know that the measure of angle 1 plus the measure of angle 2 is 90 degrees. That's my definition of complementary. Next, now that I have this value here, the measure of angle 1, I know that's 3x plus 1. The measure of angle 2, I know that's 44. So I'm going to substitute my numeric values. 3x plus 1 plus 44 equals 90. That's substitution. Now I complete my algebra steps, combine my like terms. 3x plus 45 equals 90. We're just going to say we simplified. Then I'm going to subtract 45 from both sides. And finally, I'm going to divide by 3. Remember, you are done with your proof when your last statement looks exactly like what you're trying to prove. Looking at my next example, paying attention to what information I have in my picture, I should see that this is a line, so I want to be thinking linear pair right away. I also know in my picture that the measure of angle 1 equals x plus 2, and the measure of angle 2 equals 6x plus 3, so that's given. I know in my picture that's a linear pair, so I know that angle 1 and angle 2 are linear. That's given in my diagram. Based on this idea of linear pair, I'm going to go ahead and say if I add the measure of angle 1 to the measure of angle 2, linear means 180. The reason I can say that is the linear pair postulate. And now I can go ahead and look at what I own here. Angle 1 is x plus 2. Angle 2 is 6x plus 3. I'm going to substitute those values for these. So x plus 2 plus 6x plus 3 equals 180. Substitution is what I used. Now I can combine whatever like terms I have. I should see that I have 1x and 6x, that makes 7x. 2 and 3, that makes 5. And that is just simplifying that equation. My last couple steps here, I'm going to go ahead and subtract 5 from both sides. And then I'm going to divide by 7. I know I'm done with my proof if my last statement looks like what I'm trying to prove. In my final example here, I can see that the measure of angle 1 is 58 degrees, and the measure of angle 2 is 4x. So the measure of angle 2 is 4x plus 2. I should recognize these angles are across from each other here. So angle 1 and angle 2 are vertical angles. All of this stuff is given in my diagram, or I can see that in my diagram, so I know it. I'm going to use this idea here. Vertical angles, I know something about them. I know that angle 1 is congruent to angle 2 because they're vertical angles. And that's the vertical angle theorem. Now I have to pay attention to what this symbol means. I know that when angles are congruent, they're equal. So the measure of angle 1 equals the measure of angle 2. That's the definition of congruence. Right? Now I'm almost done. I'm just going to do some substitution. So again, my angle 1 is 58 degrees. My angle 2 is 4x plus 2. So I know 58 equals 4x plus 2. Just substituting those numeric values in. Now I know I have to subtract 2 from both sides. So 56 equals 4x. I'm going to do a division. So 14 equals x. Is it exactly like what I'm trying to prove? Not quite. So I know I have to switch the order here. So I know that x equals 14. And that's the symmetric property. Now I know that I've reached the end of my proof because this is exactly like what I'm trying to prove.